Welcome to The Explainer. I am absolutely thrilled you're here today because we are taking a fascinating journey into the hidden science of the everyday world. We're going to explore how the exact same principles that dictate the taste of your favorite morning drink are literally responsible for some of the most world-changing medical breakthroughs in human history. We're talking about the science of mixing and separating. And, by the end of this explainer, you're going to look at everything from a plain glass of water to modern medicine in a completely new light.
Okay, let's dive right into this by thinking about your own kitchen. Have you ever made a mug of hot chocolate, taken that first eager sip, and realized it just tasted, well, kind of watery and disappointing? Or actually, on the flip side, have you ever poured yourself a glass of lemonade, taken a massive gulp, and instantly felt your entire face scrunch up because it was intensely, overwhelmingly sweet and sour? It's a totally universal experience. But what's actually happening in your glass there? Well, scientists have a very specific word for this exact phenomenon.
Section 1. Understanding chemical concentration, the secret behind the flavor. At its core, concentration is simply how much solute is dissolved in a certain amount of solvent. Just to quickly refresh our memory here, the solvent is the liquid doing the dissolving, usually water, and the solute is the stuff you're adding into it, like your hot chocolate powder or sugar. So when you dump a lot of solute in, you get a concentrated solution. When you only put a tiny bit in, you get a dilute solution. It's really that simple, but it completely changes the physical properties of the whole mixture.
And this brilliantly illustrates the concept. Imagine two identical glasses of water. In the first one, we stir in just one single spoonful of orange powder. The result? A dilute solution. The color is going to be super pale, and if you tasted it, the flavor would be incredibly mild. Now take the second glass. Same amount of water, but this time we stir in 4 full spoonfuls of that exact same orange powder. Boom, now we have a highly concentrated solution. The color is a deep, vibrant orange, and the taste is going to pack a seriously strong punch. More solute just means higher concentration, and that's something we can literally see with our eyes and taste on our tongues.
Cooks actually use this science of concentration every single day. Think about it. A recipe that calls for 1 teaspoon of salt gives you a perfectly pleasant, mildly salty flavor. But if you accidentally put in a tablespoon, which is 3 times as much, you've drastically changed the concentration, and yeah, you've completely ruined dinner. To put this into a broader perspective, let's consider the ocean. Ocean water has a natural salt concentration of about 35 grams per liter. That specific concentration is exactly why it tastes so overwhelmingly salty, and precisely why human bodies just cannot safely drink it.
Section 2. The Super Mixture Challenge, separating messy matter.
All right, imagine taking a clear plastic cup and dumping in these 4 totally distinct ingredients. 1 tablespoon of sand, 1 tablespoon of salt, 1 tablespoon of metallic iron filings, and a cup of warm water. You take a spoon and stir this whole concoction vigorously for 30 seconds. What you're left with is a highly tricky, incredibly messy, muddy-looking mixture. The salt completely dissolves into the warm water, the sand is just swirling around in there, and those iron filings are completely lost in the sludge. So if I handed you this cup, could you separate all 4 ingredients back into their original pure forms?
It sounds impossible, right? No way. But we can totally solve this puzzle using 3 straightforward scientific steps based purely on the physical properties of matter. Step 1 is magnetism. Before we even touch the liquid, we hold a magnet wrapped in plastic just above our messy mixture. Instantly, the iron filings, because iron is highly magnetic, of course, jump right out of the sludge and stick to the magnet. We wipe them away, and ingredient 1 is isolated. Step 2 is filtering. We pour that remaining muddy salt water through a standard coffee filter set inside a funnel. The sand particles are just way too large to pass through those tiny holes in the paper, so the sand gets trapped. Ingredient 2 isolated. But the dissolved salty water drips right on through. Finally, step 3 is evaporation. We take that perfectly clear but highly salty water, pour it into a shallow dish, and leave it in a warm, sunny spot. Over a day or two, the water turns into a gas and floats away, leaving behind pure, solid white salt crystals.
So the crucial point here is that by understanding the unique properties of each substance, we can systematically deconstruct all that chaos. Just like a scientist in a lab, we can record our results cleanly. Step 1 used magnetism to pull out the iron. Step 2 used filtering to trap the sand. And Step 3 used evaporation to leave behind the salt. We started with an inseparable mess, and through a totally logical sequence, we completely reversed the mixture, the whole shebang.
Let's take a step back for a second and see how this really builds your critical thinking. Why did we use these methods in this exact order? I want you to think about what would have happened if we tried to pour the mixture through the filter before using the magnet. If we did that, the iron filings and the sand would have both gotten stuck in the filter paper together, right? Creating a brand new, completely unseparated mess. Science isn't just about the tools you use, it's about the sequence and the logic in which you apply them. It's like a giant puzzle.
Section 3. Alice Ball's Life-Saving Chemistry. When separation saves lives.
I want to introduce you to an extraordinary scientist named Alice Ball. Born in Seattle in 1892, she developed a deep, deep love for chemistry early on. She was a literal trailblazer, becoming both the very first woman and the very first African American to ever earn a master's degree in chemistry from the University of Hawaii. At just 23 years old, her deep understanding of chemical separation led to a monumental medical breakthrough. Tragically, Alice died at the incredibly young age of 24, right before she could even publish her work. And for years, another scientist actually took the credit for her phenomenal discovery. But today, her legacy is rightly honored, and you're about to see why.
So what exactly did she do that was so groundbreaking? Well, in the early 1900s, the best-known treatment for Hansen's disease, which is often called leprosy, was oil extracted from the chalmogra tree. But there was a massive problem. The oil was incredibly thick. Much like oil and water in your kitchen, it just would not mix with the human body's fluids. It couldn't be absorbed, making it incredibly painful and basically ineffective to inject. The stakes here were literal life or death for thousands of people. Alice Ball used those exact same principles of chemistry to separate out the active healing parts of the chalmogra oil molecules. She rearranged them so that they would finally dissolve in water. She successfully created an injectable, completely absorbable form of the oil, a real game changer.
Because she understood exactly how to pull apart a complex mixture and recombine it, she created the absolute most effective treatment for Hansen's disease the world had ever seen, a standard that was used for decades. As Alice's legacy beautifully illustrates, her story reminds us that understanding how substances mix and separate can change and save lives. What starts as a simple observation about dilute and concentrated liquids in your kitchen builds the very foundation for solving complex, real-world biological crises.
So, I want to leave you with a final challenge to test your own scientific mind. Consider a brand new messy mixture, rice, salt, and paper clips, all stirred into a bowl of water. Using the properties of matter we've explored today, how would you systematically separate them? What tool would you grab first? How would you trap the rice? And how would you retrieve that salt? Think about it, map out your steps, and remember, every single time you stir your coffee or marvel at a medical breakthrough, you are witnessing the incredible, absolutely beautiful science of mixing and separating. Thanks so much for joining me on this explainer, and keep exploring.